Hey everybody, welcome to our odds and sods video. A couple of things I want to cover for you, let you know what I'm up to. We're going to just cover a bunch of general things here today. So the first thing I want to cover is on this Bendix Radio. So in the last episode on this radio in particular, we saw that the radio plays, and if you recall, we did all the recap work underneath, so we're in great shape there. The one thing that we had to do with this radio to fix it was to fix this coil. So this coil here was broken in transit, and the way these things are designed, it's obviously a very thin piece of, I don't even know what they made it out of back then because there probably wasn't plastic, but whatever it was fairly brittle, and there was a metal clip in there that was holding it in place, and I guess during transit it got bounced around and stuff. So when I got it, this thing was kind of flapping around. So how do you fix that? We want it to be stable. And as you can see here, we need to make sure we have clearance for our tuning cap, right? We don't want that to get in the way and short out and touch it. So what did we do? Well, what I did was, because there's a bracket here that holds it in place, I took a long bolt like that, and I put a piece of heat shrink on it, and I put it through the bracket here, through the coil, making sure I didn't touch any wires that may be inside, and that's always the dangerous part. And then right here, I don't know if you're going to be able to see this, maybe we can flip it this way, I put a large washer and a nut, and it's holding it in place, and it's solid. It's not going anywhere, so that's going to do us just fine there. So now that coil's good. I did check the clearance that we have here for our tuning cap, and that's going to be just fine as well. And then all I really have left to do on this thing is clean it up. And again, I want to investigate putting a dial light here in this headphone jack. This headphone jack is interesting because it's a shorting headphone jack, so you put your headphones in there and it shorts the speaker out and shuts the speaker off and you can hear with headphones. It actually does work. So I may just leave it. I don't know. It doesn't really need a light. It's a portable radio. The reason why it doesn't have a light, you can guess why, right? Because you know that this is a battery and an AC set. And when you're running on battery, last thing you want is run down your batteries with a bulb, right? So that's why there's no light in this thing. So I may just leave it. I haven't decided yet. So next thing to do on this thing is to align it and look at the case and mount it back in and see what we got to do there. So making some good progress there. So let's put this aside, and I'll show you what we're working on next here. So if you remember my last series, I basically took the design that Terry Dayton over at D-Lab made, and I created an AC variac that also had a dim bulb tester. And matter of fact, I can show you where it is. I've mounted it on my bench. That's right there, and it's perfect. It does everything I need it to do. I've rearranged my bench a little bit. I feel like Doug here, right? I've rearranged my bench, and I've now got everything where I need it. And I know why Doug rearranges his bench, because you got to be able to get to this stuff when you're working on it. So we have our AC variac there, and it's connected to the isolation transformer. Up here we have our oscilloscope. Up there we have our RF signal generator, and down here we have our audio generator. And that brings me to my next project. So what are we working on next? Well, let's dive into it. So what we're going to build next is a combination audio generator and dummy load box. And why do we need that? Well, when I work on amplifiers, for example, guitar amplifiers and bass amplifiers and all that good stuff, after I get the box working for whatever I'm doing with it, you always want to test it and make sure you've got a great signal coming out of it, right? And if you've ever seen Uncle Doug, he does that. Terry does it over at D-Lab. So, right now I have all kinds of dummy load stuff here that I have to keep on my bench, and I really want to streamline down to one device. So, again, working with our good friend Brendan, we've come up with a design which basically will handle 3 different frequencies: 15 hertz to 150, 150 hertz to 1.5, and 1.5 to 15K. So it's all we really need here. And generally, when you're working on an amp, you generally want to go in the 1K. So we'll be somewhere in the middle there. And essentially, you've got a wafer switch here, and you've got another switch here, and switch 2 will determine the multiplier. So position 1 is times 1, position 2 is 0.1, and position 3 is 0.01. And then switch 1 identifies the frequency, so 15 to 150, 150 to 1.5, and 1.5 to 15K. Pretty simple. Got a pair of Zener diodes here, 3.9 volts. You've got a 741 chip here. You've got a couple of 10K pots, which are in there. Really not much to it. What you need for this thing is a power supply. And this 741 chip will run up to 15 volts. I think the minimum on it is 8 volts, and the maximum is 15. So we're going to go right in the middle with a 12-volt power supply. Right? Now on something like this, we have to use shielded wire. So we're going to use shielded wire for the inputs that come out of it and outputs, and make sure that we're not getting any interference in there. So let's look at our power supply. So here's the power supply that we're building for this thing. Now disregard that says 220, it's supposed to be 110. But essentially what we're using is a 24-volt AC center tapped transformer. All right, on this side we've got 12 volts, on this side we have 12 volts, and here's our center tap. And we're going into a bridge rectifier. I use some 1N4007s right here. So one side of the rectifier, bridge rectifier, comes out and goes to a negative rail, which is going through a voltage regulator, which is a 7912 12-volt voltage regulator, and that gives me my negative 12 volts. Coming at the other side, we're going here through a 7812, which is a voltage regulator as well, plus 12 volts. And we have a couple of capacitors here to smooth out the DC, right? And 2 of these are electrolytics and 2 of them aren't. And these are the electrolytics right here. And essentially, it's a really simple build. I've built it already. It's right here. Here's the device. So here's our transformer, and you'll see we have, here's our AC, and there's 3 wires coming out of here going to the circuit. So these 2 are the 12-volt rails coming off the transformer, and this green one is the center tap. You'll see here I'm going through the bridge rectifier. Here's the 2 voltage regulators, here's the caps, here's the other caps, and here's our output right here. It's really simple. This part was $10. All the components in this thing, this whole thing is probably less than $20 altogether. So we have a stable, 12-volt power supply with a positive 12 volts and a negative 12 volts. So what we're going to do is we'll show you what it looks like. We'll back the shot up, and I'm going to connect my meters to this so you can look at both rails at the same time. And we'll show you how stable it is. So let me get that set up, and we'll be right back. Okay, we've got everything connected. And we've got our variac connected as well. You'll see I have the variac turned on. I have the knob all the way down, so there's 0 volts right here at the moment. But it is in variac mode, as you can see by the switch. And let's take a look at our meters. So here's our meter that's connected to the negative rail. So we expect a negative voltage there. And then here's our meter that's connected to the positive side. Let's move this light a little bit so we get rid of the glare. So essentially we're going to arm this thing, and let's see what we get. So let's go up to 40 volts first. So we're up to 43 volts that you could see right there on the variac. Okay, when we're sitting at a stable negative 6.5 and a negative 6.3. Let's go up to 100. And we're going to hit 100 on the nose right there. So at 100 volts, we're actually hitting 12 volts, which basically turns on those regulators. So at this point, the regulator's working, and it's not going to let it go much higher than that. So you've got negative 12 and you got 12.1. If I go up to 120, you'll see that the voltage is not going to change. Let's do that. And you can see it right there on the variac. We're at 120 volts. And let's look back at our meters again. And you'll see we still have a negative 12.09 and a 12.15. So that's the beauty of the voltage regulators, is that no matter what you throw through it, it's going to hold it there. Really, really good. You know, one of the things that Brendan explained to me yesterday was he showed me a diagram of what's inside these chips. And I was astounded. It was like, I don't know, 20 or 25 resistors, capacitors, all kinds of stuff built into these integrated circuits. It's amazing how that works. If I had to build out the circuit that these things are doing, you know, it would be like a really huge circuit board. So we now have a stable 12-volt power supply, plus and minus, and that will be what we're going to use to power our test equipment, which is really good. We're also going to put a watt meter on it, and I haven't decided what kind of watt meter I'm going to use yet. I have two different kinds. So I have a digital one right here, and I'll be able to see what's coming out of the speaker connection. And then I have one of these, which is an old analog one, which came out of an old realistic power meter, which I can use. So I have to decide which one I'm going to use for that. And then I'm going to mount it in a case. I haven't decided which case yet, but it will get mounted in a case, obviously, and it'll be part of my equipment. And then I don't need that, which is our audio generator, which is right there. All right. So that's what we have going on here. Let me shut this down and we'll wrap up. Okay, so I hope you found that interesting. We're going to wrap this video up here just by kind of saying we'll have this this build starting up in the next Odds and Sods video, where I may dedicate an episode to this so that we can I can show you how we build this thing out. It looks like a lot of stuff, but it's really not a lot of components. It's pretty simple. And like I said, we're going to use shielded wire on these switches. Obviously, we won't want to have a lot of noise. And we're going to have to use some heavy-duty wire on the dummy load as well. The dummy load, obviously, if you don't use proper wire, you basically dissipate energy incorrectly. And I'll explain more about that. I probably used the wrong terminology. But you have to use heavier gauge wire, especially if you're pushing power through speaker wires. So we'll talk more about that in the next episode. Hope everybody's well. I have a gig tomorrow night, so I'm not going to be on much this weekend doing this stuff, so that's why I put this out tonight. Hope everybody has a really, really good President's Day weekend, long weekend. Everybody stay safe, and we'll see you guys soon.